So this is my first video actually trying to explain part of the unit as opposed to just answering the questions. Unit 9 is all about speed, velocity, acceleration, but it's starting to introduce the idea that we can mix in calculus. So all I'm going to do is I'm going to start with a graph, and my graph is going to be a speed time graph or velocity time graph. So you would have already covered this. And what I'm going to do is I'm just going to draw any random graph. And there we have it. So we have our velocity is the line. And then looking at the graph, we can get lots of information from it. We can see that it's accelerating here. We can see that it's travelling with constant speed here. And the reason we know this, because here we can see m is clearly a positive number, as in the gradient is positive, so it's increasing in speed. Here we can see the gradient is 0. So this is how we know it's got a constant speed, or it's a flat line with the same. The other thing we also have been doing in here is saying that if we want to find distance, we can actually just find area, and the area is distance travelled. So there seems to be quite a strong link between displacement and the velocity, as well as the velocity and acceleration. And this link is all to do with the time, how long you've been doing it. So if we have a change in displacement over a given time, we get a velocity. If we have a change in velocity over a given time, we get acceleration. Well, this can be very easily adapted and give us a relationship that we can use with calculus. And to explain that, I've just changed it to look like this. So if we start with displacement being a function of x, the change in x over the change in t will give you velocity. So the change in distance over change in time is velocity. The change in velocity, so the difference in x, the difference of the difference in x over the difference in time. So basically take the second differential, you're going to get acceleration. So differentiating our displacement gives us velocity, differentiating our velocity gives us acceleration. Similarly, we can go backwards and do integration. Integrate acceleration, get velocity, integrate velocity, you get displacement. So memorizing this diagram is probably quite useful because this is going to be vital for your understanding of all of these questions.